everybody. Thank you for attending my talk. At the same moment, there is a collaboration between Josh Long and Venkat in another big room. So I'm really happy that you came to my talk and not to their talk. Tough track to be in for speakers. I would like to talk about TDD and generative AI today. We're going to investigate if this is a perfect pairing. So I would like to start with an introduction. Why am I here talking about this subject? And last year I gave a talk called The Battle of the AI Coding Assistants. I gave this talk at multiple meetups and multiple conferences, not at DevOps UK, unfortunately. But in this talk, I compared different AI coding assistants. Think GitHub Copilot, think JetBrains AI assistant, think JetGPT. And I showed off the features of those assistants. And one of the features that I showed off was the fact that they're all capable of generating tests. So you give them an implementation, and then the AI will generate tests for you. And they do that pretty well. But after one of those conferences, a discussion started, and we were discussing, and somebody asked, can it also be the other way around? Can we also write the tests ourselves, give it to the AI, and ask for an implementation? And I thought that's a very interesting idea, so let's investigate this. I started investigating, and this led to this talk. So the next thing I would like to do is a dissection of the title, because there are 3 IT concepts in the title. The first 2 are pretty obvious. The first one, of course, is TDD, test-driven development. Second one, also really obvious, generative AI. But the third one is hidden in plain sight. And the third concept is pair programming. So in this talk, I'm going to try to combine all those 3 concepts into one new thing. I'm going to spend 2 minutes on talking about every concept so everybody is on the same page. Generative AI, I'm pretty sure everybody knows what it is. It started for the big part of the world 1.5 years ago when JetGPT came out. It is the most famous one, but it isn't the only one anymore. At this moment, all big IT companies have their own generative AI out there. All those AIs are powered by a technique called large language models, and they are pretty good at generating text and generating code. And code, of course, is a very specific kind of text. Then test-driven development. We can hold an entire conference about that, but I'm just going to boil it down to write tests in advance. This is better than doing it afterwards for several reasons. This morning I heard that writing tests in advance is just fun during the keynote, so that's probably the best reason. But also, if you do it the other way around, so if you first write your implementation and then write your tests, if there's a bug in your implementation and you're going to write your test, you're not going to see that bug. So your test will see this bug as a feature, and that's a problem. If you do it the other way around, the chance of this happening is much smaller. Also, I'm a big believer of thinking about things. The more you think about things, the better your implementation will be. If you first write your tests and then write your implementation, you did a lot of thinking and your implementation will be better. So that's why I like TDD. And it also goes really well with pair programming. So let's talk about pair programming. Pair programming is writing software in pairs, really simple. The idea is you get behind the keyboard together and you will solve the issue together. Normally we have 2 roles. We have the driver, that's the one typing, that's the one creating the code, and the other one is called the observer or the navigator, and that's the one that you discuss with, that's the one that will give you live feedback while you're coding the solution. Also something that happens a lot when you're doing pair programming, that is the following. Somebody writes the tests, then you switch chairs, and then the other one will write the implementation. So, is this a perfect tripling? What we're going to do, we're going to pair program with the Gen AI. The human will write the tests, and the AI will try to write the implementation that will pass the test. So I call this test-driven generation. So instead of TDD, we have TDG. And something I would like to stress in this idea is the fact that tests have a double purpose. And the first one, of course, is obvious. We use unit tests as input. You write a unit test, we give them to the AI, and AI will try to come up with an implementation if we ask it to come up with an implementation. But I think the second one is even more important, and that's the fact that we're going to use the tests to check the output of the large language model. I assume everybody in this room has played with large language models at this point, and we all know they sometimes make things up. They prefer to give you an answer. They prefer giving an answer over giving you the factual correct answer. Small story to highlight this. A few months ago, I think actually only 1 month ago, there was a story in the news about Air Canada. Air Canada is an airliner, and as all airliners do, they have a website, and their website had a chatbot. They decided to upgrade their chatbot by using a large language model, so the output of the chatbot would be more natural. So a customer talked to the chatbot about refund policies, and as you can imagine, the large language model powering the chatbot started to make things up. So the customer made screenshots of it, and a few weeks later, he tried to refund his ticket. He called the customer service, but the people behind the customer service said, no, this is not true. The chatbot made this up. The customer said, I don't care. So the customer went to court, and the judge agreed with the customer. The judge said, I don't care if it's a human or a large language model that puts things on your website. If it's on your website, it's true. Therefore, you have to refund the ticket. So this story, I tell this story to highlight why it's really important to fact-check output of large language models. So luckily, for coding, we have a really nice way of fact-checking our implementation. We use unit tests to see if the implementation is a correct implementation. So tests in this idea have a double purpose. First, we use them as input, and secondly, we use them to check if the implementation is a correct implementation. I told you a story about Air Canada. So my name is BOUKE NIJHUIS. I'm the CTO at a company called Think ICT, and we're going to talk about TDD and Gen AI, and we're going to see if it is a perfect pairing. So I put the idea in a schema. I'm going to take you through the happy flow that starts on the left, and then we do a straight line to the right. So on the left, you see the tests. Those are used as input for the Gen AI. So we go to the Gen AI, we prompt it, we ask it for an implementation that will pass this test. We're doing happy flow, so the Gen AI will come up with a perfect solution. And that's the implementation in the middle. Then again, we're doing happy flow, so all tests will pass. And then we follow the yes arrow, and we're done. We have production-ready code because we've written perfect unit test. So the output should also be production-ready code. Notice that there are also 2 loops in this schema. Let's start with a small loop under Gen AI. I call this the code loop. Sometimes Gen AI doesn't come up with an implementation, but with an explanation. That's cool, but you cannot run tests against an explanation. Therefore, we ask it for a new implementation. Sometimes Gen AI comes up with an implementation that doesn't compile. Again, you cannot run tests against non-compiling code. So the big loop, the one on top, sometimes not all tests pass or none of the tests pass. Then we extract the errors from the test, we feed it back to the Gen AI, and we ask it to come up with an implementation that fixes the errors. And that's the idea in a nutshell behind the concept that I'm talking about. So the best way of showing this to you, of course, is a demo. Demo. And we're going to start really simple. We're going to do an odd-even test to show off the procedure. So I wrote a test called the odd-even test. And as you can see, it's really simple. It expects an odd-even object. It has one method called isEven. If you provide it with even numbers, it should return true. If you provide it with odd numbers, it should return false. So I'm going to copy this code. I'm going to go to the grandfather of AI assistants, ChatGPT, the free version, and I'm going to ask it, please give me an implementation that passes this test. And I'm going to paste the test in there. So as you can see, ChatGPT comes up with a really simple solution. I also think it's the correct solution, but why guess? Let's test it. We have unit test, right? Did I copy the code? No, let's do it again. So I'm going to go to the test subject. As you can see, we have a dummy implementation. The isEven method always returns false. I'm going to select all. I'm going to paste it. Go back to the unit test, run the unit test, and we fingers crossed for a green check mark. Green check mark. Okay, it works. Really cool. This was, of course, a really simple example. So let's step it up a little bit. So the next thing we're going to do is prime number generation. Again, I have a test, prime number generator test. So pretty simple test again. So one test called under 50. we expect an object called prime number generator. It has one method called generate. It takes one input argument, which is the upper bound of the prime numbers to generate. And this is the numbers that we expect when the input is 50. So same mechanism, I'm going to copy it. I'm going to go here. I'm going to ask for a new context. Please provide an implementation that processes this test. Paste the test in there. We wait for the answer. This time the answer is much longer, so don't focus on the code. Yeah, you can read it, but we're going to test it with unit tests anyway. I'm going to copy it and go back. Go to the test. Notice that I have a dummy implementation that returns 0. Select everything. I'm going to paste it back to the test, run the test, and again, fingers crossed, green check mark. Okay, cool. The principle works. This was my talk. Goodbye. No, just kidding. I liked it a lot, but there are two big issues with this approach. And let's first talk about the big issue, and that's the fact that it is just too many manual steps. I had to copy code from my IDE to my browser. I had to type a prompt. I had to paste there. I had to copy code again. I had to go back to my IDE, paste it there, go to the run test. Talking about it makes me already tired. Sorry. So let's automate this. I've just given you a demo. There were a few steps involved. So I was thinking, how difficult can it be, right? We're just going to make a tool that does all those steps and then we're done. So I was expecting 3 to 5 evenings to finish this tool. Yeah, as we all know, everything is like a real project. Turned out to be harder than expected. So in the end, I spent, I would say, 10 evenings and a few weekends. But in the end, I had a tool. And it turns out that the IDE does a lot of work for you. And of course, I already knew that the IDE does a lot of work for me because that's why we're using IDEs, right? But it never became more apparent than when I was working on this tool. So I created a tool called the test-driven generator, and it should take away a lot of the manual steps. Wrong button again. So let me quickly take you through all of the things that the tool does, and then afterwards, of course, I will give you a demo. So you should recognize this as part of the schema that I've shown you before. And the first thing we should do, we should call the API of a generative AI. So I started out by using JetGPT. JetGPT, as you all know, is an API. You can just call it, and then it will come up with an answer. The next thing we have to do, we have to interpret the reply. So you saw me in the browser looking at the answer. There was some explanation. There was some code. I checked some copy code, and I took it to my IDE. This is a bit more difficult when you have to do this in code. You have to find the Java part in the code, and you have to get it out. Sometimes there is no code, so you have to handle all those cases. Then we have to create a file. And as we all know, in Java, the name of the file should be equal to the public class name. So you need to extract the public class name from your code. The next thing you have to do, you have to put this file in the right location. Because if the solution contains a package line, the first line in your code, you have to create the corresponding folder structure. And I'm doing all my tests in the temp folder, so I have to create the corresponding folder over there. Then we go to the next part. You have to compile both files. This is something I didn't think about because that's something the IDE always does for me. But hey, you have to compile them, otherwise you cannot run tests. After compiling, you have to load the new classes into the JVM. Again, something that the IDE does for me. I never think about that. You need to add a test library. If you want to run tests, you need the test JUnit 5 test library, otherwise you cannot run those tests. So you have to add it to your JVM. Then you have to run the test from code. I normally just click on the green triangle, tests are run, and it's done. Again, something that the IDE does for you. You have to interpret the results. If the tests fail, do all the tests succeed? You have to read it from a data structure and do something with this information. And then, in the end, you have to copy the implementation to the right project. I just told you I do all the testing in a temp folder, and once all tests pass, I copy the project back to the project where the unit test came from. Then we have the big loop. We have to extract errors once the tests do not pass. We have to feed those errors back to the generative AI. And something I learned while creating this tool is the fact that JetGPT doesn't keep track of your context. So while you're using the web, JetGPT on the web, you can just talk to it and it remembers what you did before. This is not true for the API. You have to build this mechanism yourself. And lastly, I needed proper logging. So imagine this, you're using the tool and it is doing a few times the small loop, a few times the big loop. This will give you a lot of text. You have, every time you have the prompt contains the input file, you have the answers of the large language model, then you get the output from the test, the errors, and so you get a lot of loops and a lot of text. So I started out with some system out print lines, like we all do, right? But they didn't cut it in the end, so I had to add proper logging. Also, I told you I started with JetGPT, but halfway the project, I switched over to local large language models. Why? They are easier and faster than I expected. I expected that using a local LLM would be really hard. I expected a big download, 20 manual steps, and then fingers crossed if it would work. Actually, nowadays it's pretty easy with a tool called Olama. You download the tool, you run a command, and you have your local LLM running. It's also faster than I expected. I expected them to be really, really slow, like wait for a minute for an answer. It turns out it's like seconds, sometimes tens of seconds, but it is faster than I expected. So there are lots of local coding large language models out there, and I'm saying coding LLMs. There are even more general purpose LLMs out there. But after trying about 10 of them, I settled on Llama 3. It came out a few weeks ago, and it turned out to be the best for this use case. So every week there are new models coming out, and every time they're a little bit better. So we're just playing with this for 1.5 years, so imagine where we will be in 5 years. So demo time. This is for me. Always when I practice, I forget to do this. So let's get rid of all the solution of the previous demos. Oh, this is wrong, of course. Git reset. Hard. So to show you, you see, dummy implementation. If you want to run the tool is really simple. It's just a jar file, and it expects, in its simplest case, one input, a path to a JUnit 5 test file. So we're going to skip the odd even test. You're going to believe that the AI can do that, but we're going to do the prime number generator test again. So I go to the file again. I'm going to copy the file name, and I'm going to paste it over here. If you do that, you see the program starts up. We're in the first test loop, which is the big loop, and in the first code loop, which is the small loop. So we're talking to a local LLM on my machine. We're asking it to create an implementation for a test that I gave it. And as you can see, something happened. It came up with an implementation. Then we try to run the tests against the implementation. As you could see, it found one test and one test succeeded. And it put this solution back in my project. So let's see the solution, and there it is. This is not a dummy implementation. So now I did exactly the same demo as with JetGPT, but now with a tool. And as you can see, it's far less manual actions. So this tool is starting to become interesting to use because it can quickly give you your implementation. So the tool works as well. Now we have the tool, let's dive a little bit deeper into the concept. So how would you add features? In the past, when we were just building our algorithms ourselves, we would just write more algorithms, right? We would write more production code. But in this concept, we're not doing that. So how do you add features? Now, that's actually pretty simple. You write more tests. If you write more tests, and you give this to the AI, it will have to change its implementation and make sure that the new test will also pass. And then you can also think about it, if you add more tests, you add more specifications. That's another way to think about tests. Now, let's do a little demo about that. So again, I'm going to grab the prime number generation thingy, but now I'm going to... We all know we only have positive prime numbers. So if you give the code a negative upper bound, so you're asking for prime numbers below 0, the tool should throw an exception. Now, how do you code that? That's not so difficult. We go to the test over here, and we're going to add a test. So what I'm going to do, I like this a lot. People use the new IntelliJ one-line large language model completion. So I have under 50, and now it wants to create an over 50. It's not what I want, but I think it's pretty smart. I'm going to call it negative input. So for people who know, yeah, this works as well. Very good suggestion. What we're going to do, we're going to use something called an assert throws. People who have used JUnit before know this. So first you have to specify the exception that you expect. So I expect a runtime exception, this one. And then you provide a lambda, and look at that. So you see how smart this AI is? This is exactly what I want, right? So I'm going to press tab. This is the test case I want to test. Now let's run it. It should fail. Yeah, you see, it fails. Let's run both of them actually, because that's better for the next time. Okay, so I'm gonna go back to my tool, and I'm just gonna ask it to come up with a new implementation. So it's exactly the same command, but now the file contains 2 tests, and hopefully, oh, you see, pretty smart, pretty quick. It found 2 tests over here, and 2 succeeded. Now let's have a look at the implementation. And as you can see, it added 3 lines to make sure that it throws an exception whenever there is a negative input. So add features by adding tests. So what about existing code? So what I've shown you is I've shown you test cases, and I used them to come up with new code. But we're all developers, right? And everybody has written unit tests. Probably everybody in this room has written more than 100 unit tests in his life. You can also apply this tool on existing tests. And if you do that, let's see what happens. Maybe the AI comes up with something better that you wrote. You never know. Actually, it happened in my case, and I will explain. So I'm going to do another demo, and it's on the code container. So in the tool is a class called code container. And I told you before, it has 2 features. Several features. First, it holds the code. So you extract the code from the answer from the AI assistant. But then we have to be able to extract the public class name. That we need that for the file name, so we can create the right file name. And then we have to be able to extract the package name, so we can create a corresponding folder structure, so that we can compile and run the code. And as you all know, the best way to do this is by using regular expressions. But I have a little confession to make. I am really bad at regular expressions. So I wrote a really crappy string manipulation solution. Kind of worked, but the more tests I added, the worse it became. So I decided, let's use the tool to improve the tool. Now I'm going to show you the code container test. That's over here. And let's start at the top. So the first thing we have to do is file name extraction. I created some implementations over here, really small implementations. I put random spaces and spots. Notice that I have classes and public classes. And here you see the expected outcome. So this should be the file name. And notice that I also put messages everywhere. Why? If you put messages behind your test cases, the feedback to the large language model is better, and therefore it comes up with better solutions. So it's easier for the large language model to understand what's going wrong. And I do the same for package name extraction. Again, spaces in all kinds of spots. Notice that I have packages with 1 level, but I also have multiple level packages. And package, of course, is an optional thing, so you can also have code without package. Here you see again the preferred outcome, and again I provided messages to help the large language model. So let's copy the path of this class. We go over here, I remove the last input, and I paste the path of the file that's currently on top of the screen. So this is already a lot more difficult than prime number generation. When I practice for this talk, 50% of the times the local language model is capable of solving this issue. Let's give it a little bit time. As you can see, it came up with an implementation, but when you run the tests against it, it failed. Now let's have a little look of what's happening underneath the hood. So there's always a file called the generated log, and you can see what we're using. So we're using Olama, and we're using Llama 3. Now here's the prompt, then there's the input, which is the test file. And now here's the received answer. It came up with an implementation. It is even a regular expression implementation. So let's see which test is failing. The test with the name failed. So let's see what happens. So interesting thing, I expected the nl.happyflow, but it already translated the dot in there to a /. It's too smart. I'm asking for the package name, but it's already working towards a file structure. It stops after 5 attempts, no solution found. And let's quickly scroll through the code to see what if it kept making the same mistake. Same mistake, you see? Slash. Now something else went wrong. So the solution changed throughout the runs, but in the end it didn't finish. I'm going to give it one more attempt. And if it doesn't find a solution within 30 seconds, I'm going to kill it. And we're going to grab out the big guns. So what do you do if the tool doesn't work properly with your local large language model? You switch over to a cloud large language model because those are so much more powerful. And so I'm really happy with the local ones, but they do not compare to the big ones in the cloud. I'm going to kill it because I'm tired of waiting. So if you, with this tool, you can also specify the large language model that you want to use. By default, it goes to the local one and it uses Llama 3, but you can specify it. But then you also have to use flags. So I have to add a few things over here. So now I have a test file, wrong button. And I'm going to specify that it's use JetGPT. So I gave it a family. You can also specify the exact type. So by default, when I say the family is JetGPT, it goes to GPT-4. GPT-4 is not the most powerful one out there. Nowadays, we also have GPT-4 Turbo. So it's doing exactly the same, but it's not going to the local large language model. It's now going to the cloud, talking to JetGPT-4. And normally it is a one-shot solution, but hey, live demo. So let's see what happens. Let's give it a little bit of time. Let's go to the file. It's this file over here. We go to the top, and now you see it said before Llama and Llama 3. Now it says GPT-4. Let's see what's going wrong in here. So it comes up with a Java implementation, and oh wow, it comes up with a string manipulation solution. It doesn't even try to use regular expressions. Let's give it a little bit more time. And otherwise I restart it. I'm pretty sure then it will solve the issue. Interesting. While we're waiting, any questions so far? Yes.
Yeah, I was wondering, have you tried this with Claude at all?
Very good question. Let me repeat it for the people who watch this on YouTube. Did you try it with Claude, the other big AI out there? No, I did not. I have a slide in the future that's called Future. And one of the things in there is I would like to add more large language models. It doesn't seem to work, so I'm going to kill it. And I'm going to retry it one more time. And actually, I expect a one-shot solution because that's what it normally does when I ask it for a solution. Any more questions to fill up the time?
So you fed back the test and then you got the code. Have you fed the code and then see if it takes more tests, or is it like more or less the same?
So can you repeat your question? Sorry.
You fed the test and then you got the code.
Yeah, the implementation.
If you feed the code, does it give you more tests?
Yeah, if I understand your question correct, you're asking you feed a test, you get an implementation, but if you give it an implementation, will it give you more tests? Yeah, that's possible, but I didn't do that for this demo. The entire idea is I write the test and I use the test to check them. So I don't want the AI to write tests for me. While we were doing the questions, a solution is found. Whew, luckily. So let's close this, let's go to the solution, and as you can see, it came up with a pattern matching solution, which solved all the test cases. So you can use the tool to run it with your existing test case to see if it comes up with something better. And in this case, it did, because I came up with a really crappy string manipulation solution. So the second thing I didn't like about the current version of the tool is the fact that it cannot handle libraries or frameworks. Because it's really good with generating plain Java code, but who is working with plain Java code on this job? Everybody's using libraries and frameworks. So the current implementation cannot do that. How should you be capable of, if you have a test file, how should you extract which libraries and frameworks are used? I think that's impossible. So I started thinking, how can I solve this problem? How can I make sure that this tool also can handle libraries and frameworks? How can I make sure that it can run Spring Boot applications, for instance? And after some thinking, I quickly came out at the build system. The build system, in Java, it's normally Maven or Gradle, knows about your dependencies. It knows which libraries and frameworks you are using. Therefore, I decided to create a Maven plugin. So the plugin knows about your dependencies. It's part of your build system. That's the entire idea. So I expected it to load all the dependencies in my JVM so I could quickly run the program. Turns out to be untrue. If you create a Maven plugin, it does not load all dependencies for you, but luckily you have easy access to all dependencies. It just gives you a list with paths to jar files or directories. And once you have this, you can write your own custom class loader. This is not a hard thing to do, but I never did it before. But I created a custom class loader and I loaded all the dependencies myself. And it was also another interesting thing. If you use this tool and you go through the loops, sometimes you have an implementation and some of the tests fail. But then you ask for a new implementation, so you get a new implementation. What you want to do, you want to unload the old implementation and you want to load the new one. This is not something that class loaders support by default, and you cannot unload stuff. So what I had to do, I had to invent some mechanism myself, which is pretty easy. You just throw away your entire custom class loader and you create a new one. So I chose a Maven plugin. That's because I'm more familiar with Maven than Gradle, but I'm pretty sure this also works for Gradle. Again, demo time. What we're going to do, I'm pressing my right button, but nothing happens. There it is. What we're going to do a simple Spring Boot endpoint test. So let me show you the endpoint test. So what do we have here? We have a simple Spring Boot test. We used the REST template. So over here, you do a get on the root of your URL. The port is always random in tests, and we expect it to return hello world, right? Simple test. So this is a Maven plugin. So we have a POM file. Let's go to the POM file. There's a lot of stuff in there. It's not interesting. The most interesting part is here. We have a new plugin called the Test-Driven Generation Maven plugin. And then the most interesting part is the configuration. Remember, the most important input that we have is the path to the test file. So now it's in here. And there's also stuff over here. You can modify anything you want. But for now, I'm just going to use the defaults. Let me first start it before I talk a little bit more. So now we're going to do Maven test-driven generate. So this will use the stuff on top. So what you can change the family, you can change the model, you can change the timeout, you can change the server, you can change the prompt if you want to play with prompts. So that's the idea. You remember this logging, it looks the same as the jar files, and underneath this plugin of course uses the same jar file, but now it has access to your build system, so it has access to your dependencies, and therefore it can come up with solutions for this problem. Now, as you can see, it's not going well. The local large language model didn't even come up with an implementation. If there would have been an implementation, you would have seen tests found and tests succeeded. Now let's give it one more try. But now we're really on the edge of what a local large language model can do. I would say in 10% of my rehearsals, the local large language model can solve this. How I'm doing for time? Yeah, pretty reasonable. I'm gonna kill it anyway because who likes waiting? So what we're going to do, we're just going to go to our ChatGPT. And ChatGPT kind of left me hanging in my last demo, so I hope it will perform better now. So exactly the same as the previous demo. Instead of using a local LLM, we're now going to a cloud LLM. And normally when I practice, it is a one-shot solution, but that's what I said the previous time. Hey, build success. So let's see what happens. So in here, it created a Hello World application, which is a Spring Boot application. It is a REST controller. It has one get mapping and it returns Hello World. So this is exactly the implementation that we expected. Again, this is a little bit simple, so let's step it up a notch. I created another test with a little bit more difficult problem, which is called the endpoint age test. And again, it's a Spring, let me make some space. Again, it's a Spring Boot test. And I have 4 test cases here. The idea is you give it a birth date and it returns to you the age of the person. And so if you're born 1st of January this year, you're 0. 1st of January 2020, you're 4. 1st of January of 2000, you're 24. And trick question, if you're on the last day of 2000, you still have to become 24, so you're 23. Now, let's go to the POM file. And let's change this point over here. And then we rerun the tool. So I think this is a, I would say, interesting problem. This is something, if I had to write it myself, I had to think about. It's not trivial. Let's see how GPT-4 performs. I can already give you, when I would say normally it finds a solution. As you can see, within 10 seconds it finds a solution. Let's have a look at the solution. And now we have an age calculator application. Again, Spring Boot application, REST controller. You see, it has a get endpoint with a, how do you call this thing again? Parameter, query parameter? Oh, yeah. And then you see there's some code over here which is not trivial. First you have to parse the string into a date, and then you have to subtract the current timestamp, and then you have to extract the years from the difference. So yeah, I think this is nice. The Maven plugin works too. So now we have a way to generate code that also uses dependencies. Now we have something that we can use in our workflow at our daily job. So what does work well? Give it contained problems with well-defined boundaries. I've shown you prime number generation. I've shown you the Spring Boot age endpoint. Those are like small little problems that it can solve. Think about what you would give to a junior. So it can solve junior developer level problems. What if it doesn't work? Now, first thing you do, you check the logs. You saw me doing that a few times, and you saw which test cases were failing. The solution is actually always the same. You upgrade the large language model. You saw me upgrading from a local Llama 3 to JetGPT in the cloud. But what if that doesn't work? What are we going to do if GPT-4 Turbo can also not solve our problem or any other large language model out there? Now, yeah, in that case, at least you have the unit test. You didn't lose a lot of time, right? You always have to write unit test. In the best case, the large language model will write the implementation for you. In the worst case, you have to do it yourself. And again, you thought a lot about the solution. You also read in the logs. Yeah, so probably you will come up with a better implementation. But I really believe you didn't lose a lot of time. You've just been playing with a, in my opinion, cool tool and applying a cool concept. So pricing. Yeah, it's not too bad. It's not as bad as you think. So pricing is actually non-existent when using a local large language model. Of course, your battery will die sooner. It uses a little bit more current. Sometimes my laptop also becomes a little bit warm, but it's pretty non-existent. You probably will not notice it. Then you pay a small price when you're playing around with online AIs. Let me give you an example. Creating this tool and practicing for this talk cost me less than $10. I still have $4 left in my account. I would say that's not too bad. I do think it becomes really pricey when you start using it a lot. But still, this is also something that will be better over time. Every month, every few months there are better and cheaper large language models out there. The ones on your machine are getting better. The one in the cloud are getting better and are getting cheaper. So at a given point, this becomes reasonable and payable. So can I use this myself? Yes, you can. After this talk on Twitter, or X, like it's called nowadays, I will share links. I will share 4 links. The first link will be of the project that produces the jar file. I will give you the code to the repository that creates the Maven plugin. I'll give you the code to the examples I just gave during this talk, and I will give you the link to this presentation. Warning, this is proof of concept level. This is not production code. There are ugly hacks in there. Of course, I wanted to write something cool and something production level, but it took far more time than I expected. And it is to test out an idea. So for now, it is proof of concept level. I hope to make it better in the future. Pull requests are accepted. So future, what do I want to add to this tool? I really would like to add the option to provide multiple test files. Currently, it only accepts 1 test file, and I think it's a small fix to let it accept multiple test files. I would like it to accept, now we're talking about the output side. Currently, it only accepts answers in which there is 1 big piece of code that's exactly 1 file. But sometimes the AI comes up with multiple files. In case of Spring Boot, you can have multiple files and that together is a solution. And sometimes when it comes up with new implementation, it tells you, change the method from the previous implementation with this. So it sometimes comes up with partial solutions. The tool currently cannot handle that, but it would be much better if it could. Then I also really would like to have a hybrid mode. So you write part of the solution yourself, but you leave a few commands like to do, AI fix this for me. You give it to the tool and then the AI only fixes that part. So you can work together, which is always nice. Then there wasn't just a question about Claude. I would like to add more generative AIs. It's not so difficult. All the APIs are alike. I also would like to add other test frameworks. There are more test frameworks out there next to JUnit. Shouldn't be too hard as well. Just a little bit of work. Just have to find the evenings. Other languages. This is probably not something I'm going to do, but hey, if it works for Java, it should also work for all other programming languages out there. And this is my end goal. Imagine this scenario. You wrote a test case, you right click and you say generate implementation. You wait a few seconds and bam, there's the implementation. So this is where I'm going to stop. But this is not the end goal of the idea. I really hope that it will be part of Copilot or AI assistants. If I can write a simple proof of concept thingy, they can write it for sure. And how cool would it be if you ask Copilot or AI assistant to, hey, give me an implementation of this. So if there are people from GitHub, Microsoft, JetBrains in the room, please make this happen. It would make me so happy. So conclusion. TDD and GenAI is a perfect pairing. I've shown you multiple demos in which it worked really well. The principle works. That's what the demo showed. And I think the most important part of this presentation is the fact that tests have 2 purposes. It is an input, but that's the minor one. The major one is you use the test to check the output of the large language model. And I think that is the real value of this proposition. Remember, I just shown you how you can use unit tests to check the correctness of code. But I think every large language model out there, not only the coding ones, would benefit from checking their output for correctness. Remember the Air Canada story? I think this is a golden combination. If we can find also in the other domain something to check the large language models, they become even more useful than they already are. Remember the Air Canada story. Thank you. If you have questions, please come to me down here afterwards. I prefer one-on-one questions. Feedback is more than welcome. Please leave some feedback in the app or just talk to me. Thank you for listening to me. I hope everybody learned something new. Enjoy the remainder of the conference. Bye-bye.